third attempt at the video, believe it or not. I made a few mistakes. So let's start with this one. Copy X, B, and then go like this. All right, so let's see if I can do a better job. Again, we have two equations. We have two variables in each equation. I can't solve it the way that it is, but I can write one in terms of a variable and use that to substitute in the second equation. So in this particular example, I hope you realize that this one is what you want to isolate because it's the easiest. So let's take that. We got x minus 2y equals negative 13. So you do it, we want to isolate, x is going to be all by itself. And in order to do that, we have to get rid of the minus 2y. So let's just kick that guy over to the other side. But change the sign of the particular term, which was negative, now it's positive. Ta-da, done. That's, I guess, old school. In the United States, we actually do plus 2y because we are so focused on telling you guys how it's an equation, so we have to keep things balanced. Whatever you do to one side, you do it to the other side. I guess that works as well. So that's that. X stays alone, and you get the same exact result. So this particular equation is now going to be written as this. I'm going to just cross this out so that we don't get confused. So here are my two equations. 6x plus 4y minus equals negative 14, and x equals 2y minus 13. I'm going to take what I just found, what I just rewrote, and use that. And I'm going to replace this x with this expression. So we're going to get 6, 2y minus 13 plus 4y equals negative 14. That allows me to have an equation with one variable, which I can obviously solve. So we get 12y minus 78 plus 4y equals negative 14. Combine like terms, we get 16y equals negative 78 equals negative 14. It's a two-step equation, guys. Plus 78 on both sides. So we get 16y equals, what is that, 64? Divide both sides by 16, and y equals 4. So what are my coordinates? My y coordinate is 4. Now I need to know what my x coordinate is. Let's take that. So we're going to substitute here. So x equals 2y minus 13. So wherever I see y, I'm going to replace it with 4. So x equals 2 times 4 minus 13. 2 times 4 is 8, minus 13 is negative 5. So there's my x value. Now, this negative 5, 1, 2, 3, 4, 5, and 4, 1, 2, 3, 4, is a point where these two lines, line 1 and line 2, would cross. I know this is not part of your homework. Now again, so the last part of your homework was to check, right? So we're going to take either equation. Let's check 6x. I forgot to do that. So 6 times negative 5 plus 4 times 4 equals negative 14. Right? I replace the x value is negative 5 and 4 value is 4. So we get negative 30 plus 16 equals negative 14, and that is definitely true. So that point right here is where those two lines meet. So let me just rewrite them. Allow me to rewrite them. So the first equation, I'm actually going to get y equals, let's see, 6x, y equals negative 6x minus 14 divided by 4 divided by 4. So y equals negative 3 over 2x minus 7. The second equation, y equals x plus 13. So it's 2y, sorry. And then y equals x over 2 plus 6.5. So those are my two lines. So one, we have a line that goes down, and the other one, the slope is positive, goes up. So let me try to see if I'm correct here. The y-intercept is negative 7. 1, 2, 3, 4, 5, 6, 7. So it's a slope that goes down. 1, 2, 3 to the right. 1, 2, 3 to the right. So 1, 2, 3 to the right. Unless I'm wrong. No, yeah, that's right. 1, 2, 3 to the right, to the right. Give me a moment, guys. Y equals negative 6x minus 14 divided by 4 is 302. Oh, here's my mistake. 14 divided by 4 is not 7. Of course not. 14 divided by 4, and let me see, 14 divided by 4, that's 3.5. That was my mistake. So the y-intercept is negative 3.5. That makes, so 3.5, 1, 2, 3.5. So here's my y-intercept. So we're going to go 3 up to the right, 1, 2, 3 to the right. Here's another point. So I can connect. This is my first equation, right? This is the equation 6x plus 4y equals negative 14. Or sorry, I should have written that. Y equals, and I rewrote that as negative 3 over 2x minus 3.5. And the other equation is the positive one, right? So the y-intercept is 6.5. Let me change that. 1, 2, 3, 4, 5, 6.5. And it's, the slope is 1 over 2, so 1 over to the right. Sorry, 1 over to the right. 1 over to the right. So again, it's a line that looks like that. This is my second line. Y equals half x plus 6.5. Okay, and which is this one. So this is the point of intersection, and that's the point negative 5, 4, and that's where they intersect. And that's what we're doing, right? So we just found it algebraically, and this one is a more visual method. Right? So that's that for that one. So this one, x, so v. Okay, so again, we have to rewrite one of them. It doesn't, well, like I said, subjective, right, as to which one. So you can, I'm going to choose, so this is equation 1, I'm going to equation 2. Equation 2, negative 2x plus 4y equals 12. I'm going to make it look like that. So let's throw the 4y to the other side. So net minus 4y minus 4y. And we end up getting, change colors, negative 2x. These two go away. Negative 4y plus 12. Now divide everything by negative 2. Finally gets our variable isolated, and we get 2y minus 6. Okay, so this fell over here. I'm going to rewrite it as that. So let me just cross it out so we don't confuse that anymore. Okay, so just like before, on the top equation, wherever we see the x, I'm going to replace it with 2y minus 6. So we get 5, 2y minus 6 minus 6y equals negative 14. That is an equation now with only one variable, which we can solve. We get 10y minus 30 minus 6y equals negative 14. We get 16y minus 30 equals negative 14. I combine the 10y, this is negative 6y. Oh, yeah, which is not, it's 4y. Sorry, let me see the sign. 4y minus 30 equals negative 14. So plus 30 on both sides. We do plus 30 on both sides. Sorry. We get 4y equals, what is that, negative 14 and 30, positive 16. Divide both sides by 4, and y equals 4. That was easy. Now we got to find out what, so again, we have a point, and we have 4. Let's find out the x value. Take that equation x equals 2y minus 6. Replace the y with 4, and we got x equals 2 times 4 minus 6. X equals 8 minus 2, which is 2. So here's my point of intersection. Oh, and I think I forgot to check in the prior example. So let's take this equation here, see if the point 2, 4 works. So we're going to get 5 times 2 minus 6 times 4 equals negative 14. 5 times 2 is 10. Minus 24 equals negative 14. And we see that it's correct. Right? So let me graph these two. So let me rewrite them. So 2, 4 is our point of intersection. And it's 2 right, 1, 2, 3, 4. Here's my point of intersection. So this is where those two lines would crisscross, right? So the first equation, well, I have to obviously rewrite both equations. So don't worry about this for now. I'm just doing it to, so I can graph it. So the first equation, okay, so we're going to get 5x. So the first equation, we're going to get negative 6y equals negative 5x minus 14. Then y equals 5 over 6x positive and plus, what's 14 divided by 6? 14 divided by 6. 14 divided by 6 is 2.33. Okay, so that's the y-intercept. So that's the first equation. So 2.33 is the y-intercept here. 5x. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Something like this. I'm going to change colors, make it a blue. And 2.33 is right about here. So that's my first one. Okay, which is y equals 5 over 6x plus 2.3. Hopefully the other one. Again, here's my point. Our point of intersection is right here. 2, 4. So hopefully the second equation, which is it's going to be 2y equals negative x minus 6. And y is going to be negative 1 over 2x minus 3. So it's a negative slope. Comes down negative 3. One, two, 3. And it's a negative slope, so it's coming down. What did I do wrong here? Hang on. 2y equals x minus 6. Right, so, sorry. So 2y equals x plus 6. I did something wrong. X plus 6. Y equals half of x plus 3. I had it backwards. Sorry. So y-intercept is 3. 1, 2, 3, and it's half of x, so 1, well, actually, 1 up, 2 to the right, okay? 1 up, 2 to the right, 1 up, 2 to the... So it's a line that goes like this. There we go. Okay, all right. So again, don't worry about that. I'm just trying to visually show you. Okay. Let's go to the next two. Or the last two. So it's that x. Again, so for me, the easiest one is the bottom one, because the ready y is already by itself. So negative 2x plus y equals 5. Let's get rid of the negative 2x to isolate our y. So you know what? Let's just throw that negative 2x to the other side, becomes positive. Ta-da, we're done. So this, we're gonna, instead of that, we're gonna use y equals 2x plus 5. Go, 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 go away. Now we can use that information. Go to equation 1 here, and wherever we see the y, we replace it with 2x plus 5. So we get 6x minus 3, 2x plus 5. equals negative 9. We get 6x minus 6x plus 5 equals 9. Now, notice that 6x minus 6x is 0, right? They cancel each other out, and we have 5 equals negative 9. So, obviously, 5 is not negative 9, and if you go back a step, there is no value of x that I can substitute here. Whatever I multiply this 6 by, I have to multiply this 6 by, so whatever x value I put in there, they will cancel each other out. So, what this means is that something weird happening here. 5 will never equal 9. So there is a little problem with these two equations. That's giving you a hint that they will never ever meet. So when is it that two lines never meet? They have to be parallel to each other. I already have the second equation in the equation of the line format. So it's y equals 2x plus 5. 5 is the y-intercept. So 1, 2, 3, 4, 5. 2 over 1. So let's put 2 over 1. Remember, right? So I don't even know if rise over 1 is a good term. So rise means 2 up and 1 to the right, right? So I know it's a, what do you call, positive slope, so my line's going to go that way, right? So let me go 2 up, 1 to the right. There's my next point, 2 up, 1 to the right. I don't need 20 points, I need 2 points. And I can connect the dots. So that's what y equals 2x plus 5 looks like. Now the other line, well, we're going to have to do a little bit of shuffling. So we have 6x minus 3y equals negative 9. So again, we're going to have to change that. And I'm going to have to rewrite that in this format. Okay, so, all right, so let's throw the 6x to the other side. So we're going to get 3y. If I throw this guy to the other side of the equation, it becomes negative. Minus 9. Divide everybody by negative 3. My y finally gets isolated. 6 divided by negative 3 is 2. Positive, by the way, negative divided by negative is positive 2x. And then 9 divided by negative 3 is positive 3. So notice there's a lot of similarity between this and that. They both have a slope of 2x, but their y-intercept is different. So the only difference between these two equations is that this blue one over here, y-intercept is 0, 1, 2, 3. It's here. So the slope is the same. I can already go ahead and draw it parallel. So there is, so the blue one, same slope, but the y-intercept is the same. Well, sorry, same slope, but the y-intercept is different. So they're both parallel to each other, right? Because their slopes are the same, and they never meet. So there's no solution. And I think we have one more. X. B. All right, likewise. This one is, we have two equations again. And we can easily see, hopefully, that equation 1 is the one we want to work with. So we have y plus 4 equals 3x. So let's isolate y. Let's throw that 4 to the other side. Change its sign. Y equals 3x minus 4. Okay, or if you want to do it this way, you can, same thing. Y equals 3x minus 4. So this I'm going to rewrite as y equals 3x minus 4. So in my second equation, wherever I see y, I'm going to replace it with 3x minus 4. 2 times 3x minus 4 minus 6x equals negative 8. My equation has a single variable. I get 6x minus 8 minus 6x equals negative 8. So, look at this. So I have 6x minus 6x. That eliminates. But this time around, I have that the left side equals the right side. So on the previous question, we have the left side not equaling the right side, which means they will never meet. But in this side, I have it that they're equal to each other. So let me just go back a couple of steps. So think about an x value. Pick on any x value. X equals 5, x equals 6, x equals 0.4442. I don't care what you get, what value of x you substitute. So replace it here and replace it here. So I multiply this 6 times 5, for example. I have to multiply this 6 times 5, right? So, and they both end up being the same value, and they being opposites, and it becomes 0. So no matter what I substitute the x's with, these two go away, leaving me with -8 and -8. So that means that we have, instead of two parallel lines, which was the case in the previous example, we're going to have one line that is here, and the other line is right on top of it. So the solution to this problem is an infinite number of solutions, where all the solutions are any point that are on top of both lines, which both lines are on top of each other, so any point on those. Just to graph it, I'm going to graph this. The first one, I already have it in the format y equals mx plus b. The second one, let me change that. So we got 2y equals -6x equals -8, but what the heck? Hang on, equals 2y minus 6x equals -8. So 2y equals 6x minus 8. Right, I'm throwing this guy. Becomes positive. Divide everything by 2. Y equals 3x minus 4. Notice that both equations are exactly the same. So the y-intercept is -4, which is here. The slope is 3, or better yet, 3 over 1. So we're going to go 3 up, 1, 2, 3, and 1 to the right. 1, 2, 3, and 1 to the right. 1, 2, 3, and 1 to the right. And it's positive, so it matches, right? So we have y equals 3x plus -4. I'm going to change colors here, and the other line is exactly the same, and it's also on top. So the solution here would be any point on the line is a solution. Is a solution to the system here, to the equations, to both equations. Okay, so if you picked any point on this line and you substitute in equation 1, equation 2, it would make both of them be okay. All right, so hopefully with these examples and the one from yesterday, you're okay to go. Okay, is this the last one? I'm done. Yes, I'm done. Okay.